Hello everyone, today we're going to be doing some coordinate proofs. Okay, so we're going to be proving that things are a certain shape or different things on the coordinate grid. So if you want to print out some guided notes that'll kind of help you out as we're going through this, you can go back to the Canvas assignment page and you'll see guided notes at the top of the page. You don't have to have them. You can just write out what you see on each slide and you'll be fine. So if you want to do that, take a minute, go back and do that. But let's go ahead and look at this. So when I'm proving things on the coordinate grid, things that we're going to be showing is we're going to be showing that things are parallel, we're going to be showing that things are congruent, or things that are perpendicular. So if I need to show that something is parallel, all I have to do is I have to find the slope of those two things and show that those slopes are exactly the same. Okay, if I can show that they have the same slope, then those two things are parallel to each other. If I'm trying to show that two things are congruent, okay, I'm going to solve for the distance of that side. And if those distances are exactly the same, then those things are congruent. Okay, and then if I want to show that two things are perpendicular, I'm going to find the slope again. And if those slopes are opposite reciprocals, the slope of the consecutive sides that I have, if they are opposite reciprocals, then those two sides are perpendicular to each other. So that's kind of how we're going to be proving things, okay? So the shapes that we're going to be looking at, the first one is a parallelogram. If I want to prove that something is a parallelogram, I only have to show one thing. All I have to do is show that both pairs of opposite sides are parallel. So what I'm going to do is I'm going to find the slope of my opposite sides. If those slopes are exactly the same, then this shape is a parallelogram. If I want to prove that something is a rectangle, I have to do two things. Okay, so first of all, a rectangle is a parallelogram. So I'm going to have to show that this thing is a parallelogram. I'm going to have to find the slope of my opposite sides and show that those slopes are exactly the same. We're also going to show that we have four right angles. Okay, so we have to have those two things, parallelogram and four right angles. So we're going to show that the slopes of my consecutive sides are opposite reciprocals of each other. If I want to prove that something is a rhombus, so a rhombus is a shape that has four congruent sides, and more specifically, it's a parallelogram that has four congruent sides. So I have two things that I have to show in this case. I have to show that this thing is a parallelogram. So again, we're finding slope and showing those opposite slopes are the same. And I have to show that I have four congruent sides. So I'm going to find the length of each side and show that those sides are the exact same length. If I can show those two things, then this is a rhombus. The next shape is a square. So a square, I actually have to prove three different things. First thing, I'm going to show that it is a parallelogram. So again, find the slopes, show that the opposite sides have the same slope. Show that consecutive sides are perpendicular. So I already have the slopes, so I just need to show that the consecutive sides have opposite reciprocal slopes, and then show that we have four congruent sides. So show that all the sides have the same length. If I can show those three things, then I know that my shape is a square. And then we're also going to look at different types of triangles. So different types of triangles we'll see. We'll have scalene triangles. So scalene means that all three of my sides are different. So what I would do here is I would find the length of each side. If all of those lengths are different, then that triangle is scalene. Another type of triangle is the isosceles, okay? So if I have an isosceles triangle, then two sides are congruent. So again, what I'm going to do is find the length of each side. If I can show that two of those sides are the same, then it is isosceles. The next triangle is equilateral. Equilateral means all three sides are the same. So you're going to find the length of each side of your triangle and show that they are all the same length. And then a right triangle. So right triangle just means that we have one right angle. So all we have to do is show that two of the three sides are perpendicular. So two sides have a slope. We're going to find the slope of all three sides and show that two of them are opposite reciprocals of each other. So let's look at an example of doing a coordinate proof. So here it says the vertices of A, B, C, D are given here. So I've got point A at -4, 2. And hold on a minute. If you want to print out this handout is at the bottom of the page that you see on Canvas. If you go down, the assignment is listed at the bottom. This is part of the assignment for today. So we have point A at -4, 2. Point B at 3, 2. Point C at 1, -1. And then D at -6, -1. Okay, so connect these dots and we get this. And this problem is asking me to prove that ABCD is a parallelogram by showing that both pairs of opposite sides are parallel. So I have to find the slope of my opposite sides. If those slopes are exactly the same, then they are parallel. So let's start with the slope of AB. Okay, so if I'm looking at line AB to go from A to B, so my rise, I'm not rising at all, so my rise is 0. My run, I'm actually running how far? That is 7. Okay, so we're rising 0 and running 7. So that would be 0 over 7, which is just going to be a slope of 0. Okay, the second one, we're going to find the slope of DC because that's the opposite side of AB. So again, if I'm going from D to C, my rise again is 0 and my run is 7. So it'd be 0 over 7, which just ends up being 0. Okay, so I have these two slopes here, and since they are the same, we can say that side AB is parallel to side DC. Okay, again, reminder, whenever you see that symbol right there, that means the things are parallel to each other. Okay, so we can say that those sides are parallel. So now we have to show that the other set of sides are parallel. So first we're going to find the slope of AD. Okay, so let's go from left to right. So let's start at D. I'm going to rise 1, 2, 3 and run 1, 2. So my slope is going to be 3 over 2. And then our opposite side would be BC. So let's find the slope of BC. So if I'm starting, I'm going to go left to right here. So start at C, and we rise 1, 2, 3. We run 1, 2. So again, that is also 3 over 2. Okay, so now these also have the same slope. So I can also say that AD is parallel to BC. Okay, so now that's my goal. That's all I had to do is show that these two sets of sides are parallel to each other. So we need to write a statement at the end here, summarizing our proof here. So we're going to say, since both pairs of opposite sides are parallel, I can use a symbol there, we're going to say that A, B, C, D is a parallelogram. And that's it. That is our proof. We've used coordinates to prove this thing is definitely a parallelogram. Okay, here's another example. So here we're given a triangle, and we're given these coordinates. Let's graph it. X is -2, 5. So X would be right there. Y is 1, -1, so that's going to be here. Z is 4, 2, so 4, 2 is going to be there. Okay, and just connect your dots, and that's going to create our triangle there. All right, so now we want to prove that XYZ is an isosceles triangle. So we want to show that two of these sides are exactly the same. Okay, so if you're finding distance, you can either use Pythagorean theorem or distance formula. So let's just use distance formula here. So side XY, let's start with that one. So XY is equal to the square root of, okay, and the distance formula is just this: D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of that. Okay, and remember this part is just saying, what is the difference between my x's and what's the difference between my y's? Okay, so going from x to y, okay, so to go from x to y, the x value is actually increasing by 1, 2, 3. The y value is changing by 1, 2, 3, 4, 5, 6. Okay, so the two numbers I have here are going to be 3 and 6. So 3 squared plus 6 squared. It doesn't matter if I put a positive 6 or a negative 6 there, because when I square it, that negative goes away. So now, when I square 3, that's 9. 6 squared is 36. So 9 plus 36 is going to be root 45. And that thing actually simplifies to 3 root 5. So that's our length of xy. So now let's find yz, or xz. Let's do xz next. Okay, so again, if I'm going from x to z, we're going 1, 2, 3, 4, 5, 6. So x is changing by 6. Y is changing by 1, 2, 3. So my change of x would be 6 squared plus 3 squared, which is also the square root of 45, and that would simplify to 3 root 5. The last one, we're going to find the length of yz. Okay, so going from y to z, my x again, 1, 2, 3. My y values 1, 2, 3. So I have the square root of 3 squared plus 3 squared. Okay, so that's going to be root 18, and that will actually simplify down to 3 square root of 2. Okay, so now what we were trying to show is that exactly two sides are congruent, and we have that here. These two sides are exactly the same. Okay, so what we're going to say is that in our summary, we can say that x, y is congruent to x, z, but they are not congruent to y, z. So since that's true, since I have two sides that are same and one that is not, I can say that triangle x, y, z is an isosceles triangle. And it's important that we always summarize our proof down here. Okay, we always need to say, this is what happened, so this is true. Okay, so those are coordinate proofs. So please check out the rest of this handout. There is a key posted at the bottom so you can check your work as you go. You should be able to prove that a parallelogram is a parallelogram. You should be able to prove rectangles, rhombi, square, and then different kinds of triangles. Please let me know if you have any questions. Have a great day.